Hello everyone. Today, our group would like to take a deep dive into our favorite daily calcium source, milk. While we all know it's great for our bones and looks like a simple uniform liquid from a physical chemistry perspective, milk is actually a highly complex, unstable system. Here is the real problem. Raw milk naturally separates over time, causing the cream and fat to float to the top and leave a watery layer underneath. In the dairy industry, this separation is a massive hurdle for product shelf life and consumer appeal. By treating milk as a colloid, scientists can manipulate the microscopic forces between molecules to stop this separation entirely. Today, we are going to show you the brilliant chemistry that keeps your daily calcium source perfectly smooth and uniform from the factory to your fridge.
Thank you, my friend. So, what exactly is colloid? A colloid is a mixture where tiny microscopic particles of one substance are evenly dispersed throughout another without solving. In milk, water is the continuous phase, while microscopic proteins and fat droplets form the dispersed phase. Normally, fat and water are immersible. They actually naturally do not mix. This creates a high interfacial tension, meaning the fat droplets tend to clump together and float to the top over time. So, just what stops this from happening? Maybe we can see it. Over, my friend, to the speaker tree.
Thank you, my friend. Nature solved this oil and water conflict using a clever trick. It's called protective shield. Every tiny fat droplet in milk is coated with proteins. These proteins are amphiphilic, meaning one side attracts fat while the other attracts water, allowing them to sit between both and keep them together. The proteins protect the fat droplet in two ways. First, through electrostatic repulsion. The proteins have a negative charge, so the droplet repel each other and can match. Second, through steric hydrants. The bulky protein chains create a physical barrier that prevents the droplet from colliding. Together, these forces keep the fat droplets stable and evenly dispersed in milk.
Thank you guys. While nature started the stabilization process, the dairy industry finished the job using a factory process called homogenization. Raw milk from the farm is forced through tiny valve under massive pressure. This mechanical force violently shatters the large fat molecule into ultra-microscopic droplets, exponentially increasing their numbers but shrinking their size. This process directly exploits a fundamental rule of physical chemistry called Stokes' law. In simple terms, this law proves that the speed at which a particle floats to the top depends heavily on its radius. By making the fat droplet exponentially small, the speed at which they can float to the top drops to practically zero. In conclusion, by applying the principle of colloidal chemistry, with shrinking the particle size and using natural potential to keep them repelling each other, the dairy industry successfully transformed a naturally separating liquid into a perfectly uniform product. So, the next time you pour a glass of your daily calcium source, you know the brilliant physical chemistry keeping it smooth. That's all from us. Thank you.